the same number each time, or you're only subtracting the same number each time. And that's how this kind of relates to our idea of slope. Slope, we said, was a constant rate of change. We were adding or going up by the same amount each time. That's the same deal with an arithmetic sequence. We're going up or down by the same amount each time and creating a pattern. So talking about what's in this first box here, a sequence is just what we call in math like an ordered list of numbers. When we say ordered list, that means we could just say, well, that's the first number in the list. That's the second number in the list. That's the third number in the list. Each number in the sequence is called a term. We've used that before already. And each term has a specific position in the sequence. So it could be in like first position, second position, third position. And what makes something arithmetic is that there's a common difference. So that's the part I was talking about. You're either adding by the same amount or you're subtracting by the same amount each time. So we're going to talk about this arithmetic sequence here, and I'm going to kind of show you some like common notation and just things you'll see when we're doing this. First thing, our sequence 5, 10, 15, 20, 25. We're counting by fives. All right. So we would do the thing where we would kind of draw an arrow and say, well, we're going up by 5 each time. That's how we know it's arithmetic. We're going up by the same amount. This is what we would call the common difference. The common difference between each consecutive terms next to each other is 5. And my pen's not writing. It's loading. Common difference, 5. Each one of these is a term. So 5's a term, 10's a term, 15's a term, 20's a term, 25's a term. We would say 5 is our first term. And how we like kind of use that, this notation that we're going to use is a A for arithmetic, and a little 1 underneath it. The little 1 underneath shows like what position it's in. So this is our first term. So like if we were to go to 20, and we would want to give that a position. That's in the fourth position. It's our fourth term. So we'd write that as an A with a little 4 underneath it. So that's the fourth one. So what we can do with these arithmetic sequence, eventually we'll get to a formula where I could say, well, without counting, I could tell you by using the formula what the 65th term of this sequence is. I could do it. I could say, what's the 109th term of this sequence? I would be able to figure that out using a formula that we'll learn at the very end of the lesson. So that's basics just with arithmetic sequence. And so this is a fun part where we get to just do some basic counting for today. We're going to just practice by, and I know these are the same. We're going to make B a new one, so don't go and do B on your own. Again, copied and pasted one too many times. Write the next 3 terms of the following arithmetic sequences and state the common difference. So first thing, to be able to figure out the next terms of the sequence, we need to know what the common difference is. So if we go from -7 to -14, we're taking off 7. So we'd say, okay, well, we go -7 here. We go to -14 to -21, we're taking off another 7. We go to -21 to -28. Again, we're taking off another 7. So our common difference would be -7. And you have to have the negative sign with it, because if you just say +7, that would be implying that you're adding 7 each time, which we're not. We're taking away 7 each time. So then now that we know the common difference, we can go through and fill in the next 3 terms just by continuing to take off 7 each time. So we take 7 away from -28, you get -35. You subtract 7 again, you get -42. You subtract 7 again, you get -49. So easy enough. Again, this is kind of like just patterns. Right? And again, we're thinking how this relates. Slope is a constant rate of change. An arithmetic sequence, you have a common difference, which is, we could just say a constant rate of change between terms. All right, I'm gonna put in a new one here. Let's go. Let's say it's 5.5, 6.0, 6.5, 7.0. So my common difference is that I'm going up by a half or 0.5 each time. So there's my common difference. I can even, if I want to do it all three. So here we're going to make sure we're adding a plus 0.5. And then just doing the next three terms, we just add it each time. This would be 7.5. This would be 8.0, or just 8. And this would be 8.5. So again, just having the basics of this down. And this is more, it's not like the counting part, it's more the vocabulary. Saying, okay, this would be like A with a little 1. This is A with a little 2. This is A with a little 3. A with a little 4. Because we're going to be using a lot of this, we're going to say, okay, the third term. So we go just 3 in. So our third term, our first term. The first term is usually the most important. That's what we're going to be using in the formula that you see in the box right below what we were doing. So if we have, what this box is saying, if we have the first term of our arithmetic sequence, and we also know what the common difference is, we can write an equation to find any term of the sequence. So like I was saying, I could find the 109th term if I know the first term and the common difference. What we're going to be doing is first you would plug in your first term for A1, and then I'll have the formula up here in a second. You would plug whatever your common difference is for your D, and then whatever term you're trying to find, so if it's like the 50th term, that's going to go in for the number n when you see the formula. So the formula is, if we're trying to find the just the nth, we call it the nth term, and nth just stands for any number. We could say a to the nth, the little n below. That n is just going to stand for whatever term we want to find, whether it's the 50th, the 62nd, the 77th. That's equal to our first term, so A1 plus, we take our common difference, D, and then we multiply it by n minus 1. So whatever your n number is, you take away 1, and then you multiply it by D. So this part I don't want you to write down, but this is kind of, I just want to get how this is relating to what we've been doing. This really, it's the same thing as slope-intercept form in kind of a convoluted way. Where you think of like your y-intercept is where you're like, when we graph, that's where you're starting to count from. A1 is where we're starting to count from, so this is like our B term. Our D, our common difference, is essentially a slope, your rate of change. And you're always going to be multiplying by, like in slope-intercept form, it's our x. Here it's just our n minus 1, whatever term we're trying to find, we take away 1 from it. So if I just go back up to this example, like if we were doing -7, -14, -21, I would take -7 plus -7 times n minus 1. But we'll do this in the bottom with the new sequence. So we're going to write the general equation for the arithmetic sequence, then find the 50th term. So when you say a general equation, that first means keep all the n's in there. So general equation means keep your n's. So we're just going to plug in something for A and 1 and D to start. That's what it means by when it wants to find a general equation. Keep your n. Anywhere you see your n's, you're keeping them. You're just plugging in something for A of 1 and D. So our sequence is up at the top. It's 4, 11, 8, 5. So our common difference would be we're going down 3 each time. 4 to 11, that's taking away 3. 11 to 8, you're taking away 3. 8 to 5, you're taking away 3. So we can say that our D value is equal to 3. Should be -3. That would have been bad if I didn't do that. -3 since you're taking away 3. And then our first term, that's the other thing we need, is your 14. This is the first term you see in our sequence. So that's our A1. So what we're going to do is we're going to plug those two numbers into, this is kind of just the formula. So we would say, since we're writing our general equation, we're keeping anything that has an n in it, we're keeping. So this A of n is staying in here, replacing the A of 1 with 14. We're replacing our D with the -3. And then we're keeping in the n minus 1 as well. So again, we're keeping all of our n's in there. This is what you would call the general equation. Why we call it a general equation is that now you could give me any term, any nth term. It could be the 50th. I could plug in 50 for n quick and find out what it is. So you could give me the 102nd. I could plug in 102 for n. I would find that term as well. So if we're trying to find the 50th term, all that means is that n is going to be equal to 50 when we plug it in. So we would take our general equation, keep in the 14, -3, but now wherever we see an n, we're going to replace it with 50. So we're going to say A to the 50th is equal to 14 plus -3. And then we're going to plug in a 50 for n, 50 minus 1. And now we're going to leave this side. We never touch this side. You're not doing any math with this. This is just saying we're finding the 50th term. This is what the 50th term is going to be equal to on this side. So we have to take 50 minus 1 to start. We do anything that's in parentheses. So it'll be 14 plus -3 times 49. Which, I don't know what that is off the top of my head. 49 times 147. So it'll be 14 plus negative, because we're taking it, multiplying it by -3. -3 times 49 is -147. which will then equal, if we add 14 plus negative 147, get negative 133. And that would be your 50th term. So you can see why this is helpful. Like if I was going to say, hey, find the 50th term. You could do it by just keeping and subtracting 7 50 times, and you would eventually get here. But what if I said find the 206th term? You don't want to go through and do this 206 times. You want a quick way to get there. So you're just plugging in, finding your A1, your common difference, leaving your n's in there, plugging in your number for n. This is what, this part on the bottom here, is what your delta math focuses on.